Hello, everybody. This is Mr. Kusaj. Welcome back to part 2 of chapter 2.3. Synthetic division. What is synthetic division? Well, it's simply a shortcut for long division, which we did in part 1. Okay? If you go to your book on page 111, they really go through all the steps and all the details. But I'm going to show you a quick version where if you watch carefully, you'll pick up on it. If you don't watch carefully, you might have to go to page 111 and look at every single step by step. Okay? So, what I want to do is divide this by this, or this into this, depending on how you say it, right? So, notice that I'm missing x to the third, so I'll have to put that in. And for synthetic division, this is what you do. You take this number here, forget the x, this number here, but you switch signs. If this is plus 2, you put minus 2 here. If this would have been minus 2, then you put plus 2 here. So you do the opposite sign, okay? And then put a little corner here to separate, that's what we're dividing, into this. And all we care about here is really the numbers. We know that the powers go x to the fourth, x to the third, x squared, right? So it's 2x to the fourth, there's a 2, 0x to the third, negative 5 for the x squared, 5 for the x, and negative 2 for the lonely number without the x, right? And then I want you to skip a space and draw a bar, okay? First thing I want you to do is just bring down the first number. Just bring it down. Just write it down. Okay? So, negative 2, now I do the multiplying part. Negative 2 times 2 is negative 4. Right? So, how did I use the arrows? Yeah. So, this helped you get this number. Right? And then you add, just like you did before here. Well, you didn't really add here. You just wrote down. But it's like 2 plus nothing is 2. 0 plus negative 4 is negative 4. And you keep doing that. Now, I multiply negative 2 times negative 4, and that's going to get me this number, which is positive 8. Add, and you get 3. And you just keep going doing that. Negative 2 times 3 is negative 6. That gives you this number. You don't have to write the arrows for the assignment, but this is notes, so we're including everything. So now add. You get negative 1. Negative 2 times negative 1 is positive 3. And then, negative 2 times negative 1 is positive 2, right? And then add, and you get 0, right? So if you look at our answer, we can rewrite that answer. So this is the remainder. The last part is the remainder, which is nothing, 0. So this would be the lonely number, the number with the x, the number with x squared, and the number with x to the third. What happened to x to the fourth? Well, we divided, so we don't get an x to the fourth. If you look at the long division, you always start with one less than the original problem. So all you do is take these numbers and just maybe start from right to left. Nothing, x, x squared, x to the third. Put those x's in there, and there's your answer. That's it. You might think that, this is just as long as the long division. But actually, if you get the hang of it, it goes really, really fast. So all we did was use the numbers and then put the x's in the right place. Don't start with the remainder. That's the remainder. So this is the lonely number, the x squared number, the x to the third number, right? So that's the answer. This is our factor, right? And this must be the other factor, okay? I'm done, right? I did what I was supposed to. I divided one into the other, and I got the answer. But the way I divided was use synthetic division. Okay, the remainder theorem, okay, a rule. You can think of it like a rule. When you divide by a binomial, a factor, right? When you divide, then the remainder will always be f of this number here, but the opposite sign. Okay, f of c, whatever this number is. Okay, so let me demonstrate. Okay, here is a long division problem. So what the remainder theorem says is, if you want to know what the remainder is, forget dividing. There's a quicker way of doing it. Okay, forget dividing. You just want to know the remainder? If it's 0 or if it's something else, very easily done. Very easily done. All you need to do is do f of 2. Since it's negative 2 here, you do f of 2. What does f of 2 mean? It means to plug in 2 into your function, into your polynomial. F of 2. So that's 2 squared plus 5 times 2 minus 1. Whatever that is, that's your remainder. It came out to 13. So if I would have done this long division, my remainder in the end would have been 13. But look at the way I found the remainder. I didn't do long division. So if you ask me for the remainder, here's a shortcut, a quick way of doing it. Just plug in this number, but you got to remember it's the opposite sign. Okay, you do f of 2. Okay, so to take you back to this first one here, if somebody said, hey, I don't want to do long division here, I just want to know what the remainder is. Well, it's 0. But suppose we didn't know it was 0. Then all you do is f of negative 2. You plug in negative 2 here, and it'll come out to 0. You just found the remainder. Okay? So that's what the remainder theorem says. It says that when dividing, then the remainder will be f of this number. Okay? Maybe I shouldn't go back in the notes because you think that's further. We already wrote this down, okay? And then we went to this and wrote this down. Okay, another theorem, another rule, another thing we noticed about long division is the following. Okay? If the remainder is 0, that means that you're dealing with a factor, right? There's no remainder, it's a factor, right? Going back to those numbers, 2 into 6 is a factor. 2 is a factor. But 2 into 5, 2 is not a factor of 5 because there'll be a remainder. Same thing here. But let's assume that what we're giving you is a factor. Well, if the remainder is 0, then, okay, we already know this. If you do f of c, opposite sign, if you do f of c, it should come out to 0. Duh, we already saw that, right? It's a factor, so the remainder is going to come out 0. Then also, x minus c is a factor. This should make perfect sense. If you want to know if it yes or no, is it a factor, then you don't have to do long division. All you got to do is check to see if your remainder is 0. If your remainder comes out to 0, then you say, yes, we're dealing with a factor here. This is a factor, right? And lastly, another thing is if we were to graph it, then c would be an x-intercept. It would be a 0, right? C would be an x-intercept. So here's an example. Here's a long polynomial. Now let's check. I just want to check that these two are factors. In other words, yes or no. Is this a factor? Is this a factor? Well, if we plug this in, we should get 0 as a remainder. So what I did was, let me cover the last part here. What I did was do synthetic division, and voila, the remainder came out to 0. So that means that x plus 4 is a 0. By the way, notice opposite sign, right? I know, but there was another way of doing it. Remember the remainder theorem? All we had to do is plug in negative 4 into the long polynomial to see if it comes out to 0. And it does. If you plug in the negative 4 into the long polynomial, it comes out to 0. So we could have skipped this part and done it this way and found out, yes, it is a factor. X plus 4 is a factor. Let's check x minus 5, okay? Now it becomes kind of a debate. What's quicker for you, the synthetic division or the f of the number, plugging in the number? Whichever one is easiest for you, go ahead and do it. But now we know that this exists. This works. If you want to know what the remainder is, you just plug in the number in the factor, but opposite sign. So now 5 does come out to 0 in the end here. So yes, this is a factor and this is a factor. I checked. Both of them had remainders 0. Okay? That's it. I'll leave you with this try. Just like I did in the example, do it here. Check if the binomials are factors. Here are the binomials. Are these two factors of this trinomial? Right? There's a couple of ways of checking. It has to do with remainder 0. If yes, write in factored form. Okay? We'll talk more about, how to write the answer. Just tell me yes or no. Okay? Check this, yes or no. Check this, yes or no. Do your best. We'll talk about it in class. See you. Bye.